Good afternoon. Today we'll talk about problems on Poisson distribution. Poisson distribution has one parameter, which is lambda, and its PMF is given by e power minus lambda, lambda power x by x factorial. In this particular distribution, we talk about the cases of observing discrete values where the maximum cannot be specified until and unless the experiment is conducted. Yeah, TV ನೋಡ್ತಿರೋದು. Copy it on the first question. So the average number of customers who appear at a window of a certain bank during the working hours is 1 per minute. So per minute a person comes. So the average number of persons is given. So average customer per minute. So that is our lambda, and that is given as 1. So our x becomes number of customers who visit the bank. Or x equals number of customers who come to the bank in a minute. Now coming to the bank specifically, we mean here who come to that particular counter or that particular teller or the window. So that is our x. So clearly you can have possibilities for this x as x equals 0, 1, 2, 3 and so on. So we can say x follows Poisson distribution. Now write the PMF in the next step. P of x is equal to e power minus lambda, lambda power x by x factorial. Lambda is given as 1. Now the questions are, find the probability that in a certain and the probability that during a given minute, okay, there are two questions here, question A and question B. And question A, during a given minute, that is when we have taken the time as 1 minute only, what is the chance that there are no customers? So x, no customers in 1 minute. So why we are sticking into this particular time? That is important because when you change the time, the parameter also changes. The number of customers or no customers in 1 minute. So that will be same as x is equal to 0. So when I say 1 minute, we have lambda is equal to 1 because the average customers given us 1 per minute. So this will be e power minus 1. Now take your calculators. So you have the operation ln, shift ln will produce e and just type minus 1. So e power minus 1, then I'll have lambda to the power of x, that is 1 power minus 1, which is equal to 1 divided by 1 factorial, that is also 1. So this is equal to s to e power minus 1. Put the calculator.
0.3679.
Just press shift ln. Shift ln type ಮಾಡಿದಾಗಲೇ e ಮತ್ತೆ power symbol ಬಂದ್ಬಿಡುತ್ತೆ. -1 ಮಾತ್ರ type ಮಾಡಿ press equals. So we get 0.36 3.79. So 36% chance that one customer will be there exactly in a, sorry, no customers will be there on a given minute. So this is, for any particular minute. Next question says, what is the chance that three or more customers will appear? Three or more customers. Again, we are talking about the same time, so the lambda remains same. Okay, 3 or more is nothing but x greater than or equal to 3. Now here it is Poisson distribution. Greater than or equal to 3 means it takes all the values for 3, 4, 5, 6, 7 up to infinity. We cannot compute all those probabilities. So we use the complementary form to obtain the answer. X greater than or equal to 3, its complement form is x less than 3. So the probability of x greater than 3 will be 1 minus probability of x less than 3. Now when I say x less than 3, I have cases with x is equal to 0 or x is equal to 1 or x is equal to 2. And or indicates union. Union is mathematically plus, and all these 0, 1, 2, 3 are disjoint and mutually exclusive. Disjoint or mutually exclusive and equally likely, not equally likely. Disjoint and mutually exclusive. So your union just becomes the sum. Now compute every probability and then compute the unitary. So what is P of x equals 0? X equals 0, ಮೇಲ್ಗಡೆನೆ ಮಾಡಿದೀವಿ already. So you can directly write that 3679. Then x equals 1 is e power minus 1. And then, first one I'll 0 alwa x. E power minus lambda, lambda power 0. Minus 1 but we did. This is minus 1 power 0 divided by 0 factorial. ಯಾರು ಹೇಳಲಿಲ್ಲ. Okay, e power minus 1, then minus 1 power 1. Sorry. Okay. E power minus lambda, lambda power x by x factorial, e power minus 1, and then 1 power 1 divided by 1 factorial. So that also comes to be 0.3679 only. Then again you will have e power minus lambda, lambda power of x divided by x factorial. So this becomes 1 minus 0.3679 plus 0.3679 plus e power minus lambda into lambda square is 1 divided by 2 factorial 0.1839. ನೋಡಿ ಎಷ್ಟು ಆನ್ಸರ್ ಬಂತ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ ಮಾಡ್ಲಿಕ್ಕೆ? The answer banta. Did you get 0.08? So chance that more than 3 customers
Yes,
will
ma'am.
is just 8%.
0.0802.
Now in the next case, question B, they have changed the time in a span of 5 minutes. Now you can easily convert this into total number of customers who arrive in span of 5 minutes. Like say you have one Poisson distribution, which is x equals number of customers in a minute. Second Poisson distribution, x is number of customers again in a minute. So five such Poisson distribution, x1, x2, x3, x4, xy, all indicates the number of customers who visit the bank in 1 minute. Now when you look into x1 plus x2 plus x3 plus x4 plus x5, that becomes total number of customers coming to the bank in a span of 5 minutes. So here we are talking about sum of the Poisson distribution. Now sum of Poisson distribution is also a Poisson distribution provided the selected random variables are independent, and if the lambdas are identical, you will have the new lambda as k times of old lambda. If the lambdas are non-identical, like if I have lambda 1 plus lambda 2 plus lambda 3, lambda 4, lambda 5, the sum of the lambda becomes the parameter. Okay, so that we'll discuss in the theory class in detail. Now, whenever you have been given with a case where given lambda is for a different time and they have changed the time in the sub question, then you multiply lambda with the respective quantity, or you just take the linear scale and select the lambda. So here we are selling the average number of customer per 5 minutes. So this will be 1 into 5. So that is our new lambda. 30 minutes ಕೊಟ್ಟಿದ್ರೆ lambda will be 30 into 1. 2.5 minutes ಕೊಟ್ಟಿದ್ರೆ lambda will be 2.5 into 1. So whatever the lambda they have given in the initial case, you consider that and change it accordingly. Now sometimes lambda could be given for minutes. In the question the value will be for hours, so convert them into minutes and then obtain the value of lambda. Okay, so we got lambda, which is 5. Now what is the chance that no customer will appear? So same answer, but you will have lambda is equal to 5. So no customers in a span of 5 minutes now will be equal to p of x is equal to 0, which is e power minus lambda into lambda power x divided by x factorial. So which is just e power minus 5. That comes to 0.0067. And then next we have p, at least 2 customers. Now, do you remember the definition of at least? Is it greater than or equal to or less than or equal to?
Greater than or equal to.
Greater than or equal to. So greater than or equal to 2. So it is Poisson. Poisson ಅಲ್ಲಿ ಯಾವಾಗಲೂ ಗ್ರೇಟರ್ ದೆನ್ ಗೆ ಪ್ರಾಬಬಿಲಿಟಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಕಾಂಪ್ಲಿಮೆಂಟರಿನೇ ಯೂಸ್ ಮಾಡಬೇಕು, ಇಲ್ಲಾಂದ್ರೆ ಎಷ್ಟೊಂದು ಪ್ರಾಬಬಿಲಿಟೀಸ್ ಕಂಪ್ಯೂಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So p of x less than 2 indicates p of x equals 0 or p of x equals 1. Will be e power minus 5, 5 power 0. So we already have that value, so I'll not repeat it. 0067 plus the next one is in e power minus 5, 5 power 1 divided by 1 factorial. e power minus 5 into 5. That gives us 0.0337. ಸರಿನಾ?
0.9598.
Yeah, 0.9596. This is the answer. ಬರ್ಕೊಳ್ಳಿ ಬೇಗ, ಸ್ಟೆಪ್ಸ್ ಎಲ್ಲ ಇರಲಿ, ಡೋಂಟ್ ಸ್ಕಿಪ್ ಎನಿ ಸ್ಟೆಪ್ಸ್. ಆಗಿರೋ ನೆಕ್ಸ್ಟ್ ಒನ್ಗೆ ಹೋಗಿ. ಕ್ವೆಶನ್ಸ್ ಇದೆ ನಿಮ್ಮ ವಾಟ್ಸಪ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ, ವೆಡ್ನೆಸ್ಡೇ ಏನೋ ಥರ್ಸ್ಡೇನೋ ಕಳಿಸಿದ್ದೀನಿ ನೋಡಿ. ಎಲ್ರದ್ದು ಆಗಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಒನ್ಗೆ ಹೋಗ್ಬೋದು. ಎಷ್ಟು ಜನ ನೆನ್ನೆ ಕಾಲೇಜ್ ಕಡೆ ಬಂದಿದ್ರಿ ಇಂಜೆಕ್ಷನ್ ಚುಚ್ಸ್ಕೊಳಕ್ಕೆ? ಇನ್ನೊಂದು 10-15 ದಿನದಲ್ಲಿ ಕಾಲೇಜ್ ಶುರು ಆಗ್ಬಿಡುತ್ತೆ. ಫಸ್ಟ್ ಡೋಸ್ ಸರ್ಟಿಫಿಕೇಟ್ ಇಟ್ಕೊಂಡ್ ಬಂದ್ರೆ ಕಾಲೇಜಲ್ಲಿ ಕ್ಲಾಸಲ್ಲಿ ಕೂರ್ಸದ್ ನಾವು, ಇಲ್ಲ ಗೇಟ್ ಒಳಗೆ ಸೇರ್ಸಲ್ಲ.
ಸರ್ ವ್ಯಾಕ್ಸಿನ್ ಖಾಲಿ ಆಗೈತೆ, 5ನೇ ತಾರೀಕು ಅಂತ ಬರೋದು ನಾಳೆ.
ನೆನ್ನೆ ಹೋಗಿರ್ಲಿಲ್ವಾ?
ಇಲ್ಲ ಸರ್.
ಯಾಕೆ?
ಮೈಸೂರಿಂದ ದೂರ ಸರ್.
ಸುಮಾರು ಜನ ಬಂದಿದ್ರಲ್ಲ ನೆನ್ನೆ ನಮ್ಮ ಕಾಲೇಜ್ನವರು, ಸೆಕೆಂಡ್ ಇಯರ್ನವರು, ಫೈನಲ್ ಇಯರ್ನವರೆಲ್ಲ ಬಂದಿದ್ರು. ಒಂದು 2 ಕಾಲೇಜ್ ಸೇರಿ ಒಂದು 300 ಜನ ಇದ್ರು ನೆನ್ನೆ. ನೀವು 9 ಗಂಟೆಗೆ ಹೋಗ್ಬೇಕು. 9 ಗಂಟೆಗೆ ಹೋದ್ರೆ ಎಷ್ಟು ಶಾರ್ಟ್ಸ್ ಇರುತ್ತೆ ಅಷ್ಟು ಟೋಕನ್ ಕೊಟ್ಬಿಡ್ತಾರೆ. ನೀವು 10 ಗಂಟೆ 10:30 ಹೋದ್ರೆ ವಾಪಸ್ ಕಳಿಸ್ತಾರೆ ಖಾಲಿ ಅಂತ. ನೆಕ್ಸ್ಟ್ ನಾಳೆನೂ ಇದೆ, ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಪೂರ್ತಿ ಇದೆ ಅಂತ ಸುದ್ದಿ, ಬಟ್ ನಮ್ಗೆ ಸಂಜೆ ಗೊತ್ತಾಗತ್ತೆ. ಬಟ್ ನಾಳೆ ಗ್ಯಾರಂಟಿ ಇದೆ, ನಾಳೆ ಹೇಳಿದ್ದಾರೆ. ಸೊ ಹೋಗೋರು 9ಕ್ಕೆ ಅಲ್ಲಿ ಯೂನಿವರ್ಸಿಟಿ ನಮ್ಮ ಏನು ಮಹಾರಾಜ ಕಾಲೇಜಲ್ಲಿ ಹೆಲ್ತ್ ಸೆಂಟರ್ ಇದೆ ಗೊತ್ತಲ್ವಾ, ನಂದಿನಿ ಬೂತ್ ಹತ್ರ, ಅಲ್ಲಿ ಹೋಗಿ 9ಕ್ಕೆ ಕಾಲೇಜ್ ID ಆಧಾರ್ ಕಾರ್ಡ್ ತಕೊಂಡು.
ಸರ್ ಐಡಿನೇ ಕೊಟ್ಟಿರಲ್ಲ ಸರ್.
ಈಗ ತಕೊಂಡು ಹೋಗಿ, ಏನು ಅಡ್ಮಿಷನ್ ಸ್ಲಿಪ್ ಇದೆಯಲ್ಲ, ಪೇಮೆಂಟ್ ಸ್ಲಿಪ್. ಆಯ್ತು, ನೆಕ್ಸ್ಟ್ ಕ್ವಶನ್ ಹೋಗೋದಾ? ಆಯ್ತು, ಎಲ್ಲಾರ್ದು ಇದು ಇನ್ನ ಡೌಟ್ ಇದೆ? The next question. Bank receives on an average 6 bad checks per day. What are the probabilities that it will receive 4 bad checks on any given day, 10 bad checks on any 2 consecutive days? Okay, so given average bad checks received per day, so that is equal to 6. Therefore x is equal to number of bad checks received in a day. So that could possibly take 0, 1, 2, 3, etc. Write the PMF. First question is, what is the probability of observing 4 bad checks on a given day? On any day. So this is just P of x is equal to 4. So this will be e power minus lambda, lambda power, lambda is today. Lambda is 6, lambda power x divided by x factorial. Complete ಮಾಡಿದ ಸರಿನಾ? Next, for 2 consecutive days. So it need not be consecutive. Any 2 days are independent. So number of checks you receive today doesn't affect the number of checks that you receive tomorrow or day after tomorrow. So they are independent. So it need not be 2 consecutive days. And for any 2 days, lambda is equal to 2 times of lambda symbol. Lambda becomes 6 into 2. ಒಂದು ದಿನಕ್ಕೆ on an average 6 batch checks ಸಿಗ್ತಾ ಇದೆ. So 2 ದಿನಕ್ಕೆ it will be 2 into 6, which is equal to 12. So together on an average for 2 days you will have 12 bad checks. So now you can write your x also here, because x change ಆಗುತ್ತೆ ಅಂತ. So x now here is number of bad checks received on 2 days. So that is also 0, 1, etc. So that's why it is 4. P of 10 bad checks. So x is equal to 10. So that will be e power minus lambda, which is 12, lambda power x divided by x factorial. Hope calculator gives answer to this. ಒಟ್ಟಿಗೆ ಟೈಪ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಆನ್ಸರ್ ಬರುತ್ತೆ. ನೀವು ಇಂಡಿವಿಜುವಲ್ ಆಗಿ ಮಾಡ್ತೀನಿ. e power minus 12, 12 power 10, 12 power 10 is a very large number. So you have to type in one go, e power minus 12 into 12 power 10 divided by 10 factorial. ಒಂದೇ ಸಲ ಮಾಡಿ ಸೈಂಟಿಫಿಕ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ಅಲ್ಲಿ ಆನ್ಸರ್ ಬರುತ್ತೆ. Now imagine lambda much more larger, like say 25, 30. So in that case, our calculators and the computers fail to give answer using this particular PMF, e power minus lambda, lambda power x, because as lambda becomes larger, x becomes larger, lambda power x becomes very large number, and x factorial is also large number. So we end up getting a situation like infinity by infinity in most of the cases when our lambda and x are large. So this doesn't give us proper probabilities. So in that case, we use what called as normal distribution. So whenever we observe lambda very large in a Poisson distribution, the Poisson distribution can be approximated to normal distribution. Okay, so we'll solve one or two problems on how binomial becomes normal, how Poisson becomes normal once we discuss completely the Poisson distribution. By right now, we'll just use the given distribution. Okay. So how many if you have got this answer? 0.1048.
Sir, 0.10483.
Sir, got 1048.
ಸರಿ, ಸಿಂಪಲ್ ಕ್ಯಾಲ್ಕುಲೇಟರ್ ನವ್ರಿಗೆ ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗ್ಬೋದು. 12 / 10 ಬರೋದಿಲ್ಲ. ಆಯ್ತು, ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಹೋಗಿ. In the inspection of electrical plates by a certain electrolytic process, 0.2 imperfection is spotted on an average per minute. Find the probabilities per minute. Find the probabilities of spotting 1 perfection in 3 meters and at least 2 perfection in 5 meters. So the plate is measured in terms of meters. Change ಮಾಡ್ಕೋಬೇಕು. Change. Practical 11 ಅಲ್ವಾ? Okay. ಸೊ ಎಲ್ಲ ಕರೆಕ್ಷನ್ಸ್ ಆದ್ಮೇಲೆ ಒಟ್ಟಿಗೆ ಅಷ್ಟು ಪ್ರಾಕ್ಟಿಕಲ್ಸ್ ಫೈಲ್ ನಿಮಗೆ ಕಳಿಸ್ತೀನಿ. ನೀವು ಒಟ್ಟಿಗೆ ಪ್ರಿಂಟ್ ತಗೋಬಹುದು. ಆಯ್ತಾ? ಒಂದೊಂದೇ ಪ್ರಿಂಟ್ ತೆಗೆದು ಟೈಮು ಪೇಜ್ ಎಲ್ಲ ವೇಸ್ಟ್ ಮಾಡ್ಕೋಬೇಡಿ. ಓಕೆ, ಮಾಡಿದ್ದು ನೀವೇ ಮಾಡ್ಬಿಟ್ಟು ನಂಗೆ ಆನ್ಸರ್ ಹೇಳಿ ನೋಡೋಣ. ಕ್ವಶನ್ ಬರ್ಕೊಳ್ತಿರೋರು ಆ ಮಿನಿಟ್ ನ ಮೀಟರ್ ಅಂತ ಮಾಡ್ಕೊಳ್ಳಿ ಫಸ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಅಲ್ಲಿ.
Sir, first one is 0.3293.
1 perfection in 3 meters. So you'll define your x as number of imperfections. Imperfections in 3 meters. So that could take values like 0, 1, 2, etc. So x ಎಲ್ಲ ಬರಿಬೇಕು, PMF ಬರಿಬೇಕು, ಆಮೇಲೆ ಲ್ಯಾಂಬ್ಡಾ ಬರಿಬೇಕು, ಆಮೇಲೆ ಕಂಪ್ಯೂಟೇಷನ್ ಇದೆಲ್ಲ ಬರ್ದಾಗಿದ್ಯಾ? ಯಾರು ಮಹಿಮಾನ್ ಆನ್ಸರ್ ಹೇಳಿದ್ದು?
ಇಲ್ಲ ಸರ್, ಬರೀಲಿಲ್ಲ, ಬರೀತೀನಿ.
ಬರಿಬೇಕು. Lambda is equal to 0.2 into 3, so that becomes 0.6 imperfections per 0.6 imperfections per minutes, so 3 minutes. Now write the PMF. Oh, first question is P of x is equal to 1. 1 imperfection in 3 minutes. So we'll have e power minus 0.6 into 0.6 power 1 divided by 1 factorial, which comes to 0.3293. Correct. Next, at least 2 imperfections in 5 meters. So now x and lambda changes. So x is number of imperfections in 5 minutes. Then lambda will be 0.2 into 5, which comes to be 1.0. Now they are asking P of at least 2. That will be equal to x greater than or equal to 2. Follow the steps. Complementary form ಹಾಕಿ ಆನ್ಸರ್ ಹೇಳಿ ನೋಡೋಣ. 1 minus e power minus lambda power 0 minus e power minus lambda power 1 in 0.2642. Steps ಬೇಕಾ ಸೆಕೆಂಡ್ ಕ್ವೆಶ್ಚನ್ ಮಾಡ್ತಿದ್ದೀರಾ?
Sir, 0.0803, sir.
0803 ಬಂತಾ?
Sir, 0.0803, sir.
0803. ಓಕೆ,
ಎಸ್ ಅಷ್ಟೇ ಬರ್ತದೆ.
ನಾನೇನು ತಪ್ಪು ಮಾಡಿದೆ? 1 minus p of x equals 0 is e power minus 1.
ಸರ್ 0.2644 ಬಂತು.
ನನಗೂ ಅಷ್ಟೇ ಬಂತು ಸರ್.
0.08 ಹೆಂಗ್ ಬಂತು ಹೇಮಂತ್?
ಸರ್ 0.3679 ಪ್ಲಸ್ 0.3679 ಪ್ಲಸ್ 0.1839 ಸರ್ 1 ಮೈನಸ್ ಅಷ್ಟು.
ಅಲ್ಲ, 2 ಕನ್ಸಿಡರ್ ಆಗಲ್ವಲ್ಲ. ಕಾಂಪ್ಲಿಮೆಂಟ್ ಫಾರ್ಮ್ ಬರ್ದಾಗ ಇಟ್ ಇಸ್ ಜಸ್ಟ್ ಲೆಸ್ ದನ್, ಬಿಕಾಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ಈಕ್ವಲ್ ಟು ಇದೆ. ಸೊ ಇಟ್ ಇಸ್ 1 minus p of x less than 2. So it is just 1 minus 0 or 1.
Sir, 2 consider ಮಾಡಂಗಿಲ್ಲ sir.
ಇಲ್ಲ, ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಈಕ್ವಾಲಿಟಿ ಬಂದ್ಬಿಟ್ಟಿದೆಯಲ್ಲ. ಅಟ್ ಲೀಸ್ಟ್ ಅಂದ್ರೆ ಗ್ರೇಟರ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು. ಗ್ರೇಟರ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಗೆ ಕಾಂಪ್ಲಿಮೆಂಟರಿ ಏನು? ಲೆಸ್ ದೆನ್ ಆರ್ ಈಕ್ವಲ್ ಟು ಆಗಲ್ವಲ್ಲ. ನೀವು ಬರೀ ಗ್ರೇಟರ್ ದೆನ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಈಕ್ವಾಲಿಟಿ ಬರುತ್ತೆ. ಬಟ್ ಈಕ್ವಾಲಿಟಿ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಇರೋದ್ರಿಂದ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಕನ್ಸಿಡರ್ ಆಗಲ್ಲ. ಸೊ ಅದೊಂದು ಪ್ರಾಪರ್ಟಿ ರಿಮೂವ್ ಮಾಡಿದ್ರೆ ಸರಿ ಹೋಗುತ್ತೆ.
Okay, sir.
ನೆಕ್ಸ್ಟ್ ಒಂದಷ್ಟು ಈಕ್ವೇಶನ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೇಕು ನೀವು. ದೇ ಹ್ಯಾವ್ ಗಿವನ್ p of x equals to is equal to ಅಯ್ಯೋ ಕ್ವೆಶ್ಚನ್ಸ್ ಸರಿ. Okay. Question 4 tells in a Poisson distribution p of 2 is equal to 4 p of 3. Now p of 2 indicates p of x equals 2. and P of 3 indicates P of x equals 3. So some clue is given or some relation between two successive probabilities is given. So using this relation, you can compute the value of lambda. Now once you get your lambda, you can compute P of x equals less than 2 as well as P of x equals 3 and obtain the moment coefficient of skewness and kurtosis. So skewness kurtosis ಇನ್ನು ಮಾಡಿಲ್ಲ ನಾವು. So ಇರಲಿ, ಅದು next class ಅಲ್ಲಿ ಮಾಡ್ಕೊಳ್ಳೋಣ. So first now in this class we'll just look into computation of the probability. Okay. ಮಾಡಿ P of x equals 2 equals 4 times P of x equals 3 ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ. So let me show you.
Lambda equals 3/4.
Show a similar problem. Okay, see here. So if a random variable x follows Poisson distribution such that P of x equals 1 equals P of x equals 2. So given ಏನಿದೆ ಅದು ಬರ್ಕೊಂಡು ಅದಕ್ಕೆ ಜನರಲ್ ಪ್ರಾಬಬಿಲಿಟಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ. ಸೊ x equals 1 ಅಂತಂದ್ರೆ e power minus lambda lambda power 1 by 1 factorial. x equals 2 ಅಂದ್ರೆ e power minus lambda lambda power 2 by 2 factorial. ಸೊ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಳಿ, ನಿಮಗೆ ಲ್ಯಾಂಬ್ಡಾ ಬರುತ್ತೆ. ಬಟ್ ಇವಾಗ ನಮಗೆ ಕೊಟ್ಟಿರೋದು P of x equals 2 equals 4 times P of x equals 3. ಮಾಡಿ ಈಕ್ವೇಶನ್ ಸಾಲ್ವ್ ಮಾಡಿ ಮತ್ತೆ ಜಾಯಿನ್ ಆಗಿ